Today, on Why Do We Need to Know This, we'll learn how to do division with an area model. We'll also see that this strategy can help us divide 2, 3, and 4-digit numbers more efficiently. And we'll see that division using an area model can help us count fossils, plan a pizza party, and celebrate our school spirit week.
Why do we need to know this?
Why?
Why? Add and subtract, multiply and divide. We use math in everyday life. Why do we need to know this?
You know this.
Whoa,
Ooh, is that a claw? Or maybe a tooth?
it's gotta be a tooth.
Hey, April. Hey, Marcos.
Hey, Edicina.
Are you digging for fossils?
We sure are. Check out this tooth I found in the fossil kit.
That's pretty neat. How many fossils are in that kit?
This kit says there are 78 fossils, and it has an equal amount of 6 different kinds. I wonder how many of each kind is in here.
To find out, we need to divide 78 by 6.
I don't know how to do that in my head.
Have you tried using an area model to solve that?
An area model? I thought that was for multiplication.
It is, but we can use an area model for division too. Let's refresh our memory on using an area model for multiplication by solving 6 times 24.
We can draw a box and show one side being 6 units long and the other side being 24 units long. The area inside the box represents the answer to the multiplication problem.
We also learned that we can split this area into sections to solve it. For example, 24 can be split up by place value, making one section that is 20 units long and another one that is 4 units long.
Now we can solve 6 times 20 and 6 times 4 separately. 6 times 20 equals 120, and 6 times 4 equals 24.
Finally, we add those two areas together to find the total area. 120 plus 24 equals 144.
So this means that 6 times 24 equals 144.
Excellent. Now let's see how to use this model to solve 96 divided by 3.
But that's not a multiplication problem. How do we do that?
96 divided by 3 can be shown as a rectangle with an area of 96, where one of the sides is 3 units long and the other side is an unknown length. So if we can find this unknown length, then we will know the answer to 96 divided by 3. We can start by splitting this area into smaller parts, just like we do with multiplication. The left side will have an area of 90, and the right side will have an area of 6. Now let's solve it. We start by asking 3 times what number is 90, or as close to 90 as we can get without going over.
I know that 3 times 30 is 90.
Great! Now we need to find out how much area is left. We do that by multiplying 3 times 30, which is 90, then subtracting that from the amount of area already there.
90 minus 90 is 0.
Very good. That means we don't have any area left to divide up in this section. Now we do the same process for the next section. We ask 3 times what number is 6 or less?
I know that 3 times 2 is 6.
We show that by writing 2 here and that 3 times 2 is 6 here. Now we find out how much area is left by subtracting. 6 minus 6 equals 0. That means we don't have any area left to divide up. Now all you do is add up the numbers along the top of the box to find the total length of this side.
30 plus 2 equals 32. So this means that 96 divided by 3 is 32.
Exactly. The area model lets us break up a division problem into smaller parts that are more friendly to work with.
That's pretty useful.
Now, let's see how to use this model to solve 78 divided by 6. 78 divided by 6 can be shown as a rectangle with an area of 78, where one of the sides is 6 units long. The other side is an unknown length. If we can find this unknown length, then we have the answer to 78 divided by 6. We can start by splitting this area into smaller sections just like we do with multiplication.
One will have an area of 70, and the other will have an area of 8.
Now let's solve it. We start by asking 6 times what number is 70 or less than 70?
I know that 6 times 11 is 66.
Correct. Now we need to find out how much area is left. We do that by multiplying 6 times 11, which is 66, then subtract 70 minus 66.
70 minus 66 is 4.
Very good. Now we move this leftover area to the next section. To find how much area is in this section, we add 8 plus 4.
8 plus 4 equals 12.
Great. Now we do the same process for this section. We ask 6 times what number is 12 or less?
I know that 6 times 2 equals 12.
Excellent. Then we show that 6 times 2 is 12 by writing the 12 under the amount of area. Now we subtract.
12 minus 12 is 0. That means we don't have any area left to divide up.
Precisely. Now all you do is add up the numbers you have along the top of the box to find the total length of this side.
11 plus 2 equals 13.
Right. So this means that 78 divided by 6 equals 13.
So we have 13 of each type of fossil.
Exactly.
The area model lets us break up a division problem into smaller numbers that are more friendly to work with. That's pretty useful.
You got it. What's even more useful is that there are many ways to get to the right answer using an area model. Let me show you. Let's set up our area model in the same way. Last time we said 6 times 11 is 66. But what would happen if we use 6 times 10 instead? Let's try and find out. When we multiply 6 times 10, we get 60. Then we subtract 70 minus 60 to find out how much area is left in this section.
70 minus 60 is 10.
Right. Now we move this leftover area to the next section. To find how much area is in this section, we add 8 plus 10, which is 18. Then we do the same process in this section. We ask 6 times what number is 18 or less?
I know that 6 times 3 is 18.
Excellent. So we write the 3 above that section. Then we show that 6 times 3 is 18 by writing 18 under the amount of area. Now we subtract.
18 minus 18 is 0. That means we don't have any area left to divide up.
So to find the answer, we add up the length along the top of the box. 10 plus 3 equals 13.
Hey, that's the same answer we got before.
It is. The area model lets us divide by any amount we feel comfortable with, as long as we don't go over the total amount we have.
Does this work for any number?
It sure does. Next, let's try to divide a 3-digit number. Marcos and April are helping to organize graduation for their school, which includes pizza for all the kids and their guests.
The survey forms we sent home show we need 359 pizzas, and we want to order an equal amount of cheese, pepperoni, vegetable, and anchovy pizzas. How many of each type of pizza should we order?
We can find out by solving 359 divided by 4.
Let's set up an area model.
We will make a box showing 359 as the area. One side will have a length of 4, and the other side is unknown.
Next, we will split up 359 into 3 sections by place value. Let's split it into 300, 50, and 9.
Now let's solve one section at a time. First, 4 times what number is 300 or less?
I know that 4 times 50 equals 200, so let's write the 50 on top of the box. To find out how much area is left, we multiply 4 times 50, which is 200. Then subtract 300 minus 200.
300 minus 200 is 100. We move that amount over to the next section and add it to the 50 already there. This section now has 150.
I know that 4 times 30 is 120. So let's write 30 above that section. To find out how much area is left, we multiply 4 times 30, which is 120. Then subtract 150 minus 120.
150 minus 120 is 30. We move that amount over to the next section and add it to the 9 already there. This section now has an area of 39.
I know that 4 times 9 equals 36. So let's write the 9 on top of the box. To find out how much area is left, we multiply 4 times 9, which is 36. Then subtract 39 minus 36.
39 minus 36 equals 3.
But what do we do now? We can't split 3 into 4 equal groups.
That amount is called the remainder.
To find the answer, we add up the lengths of all 3 sections. 50 plus 30 plus 9 is 89, with a remainder of 3.
So we need to order 89 of each kind of pizza. And since we need a little more than that, we can round up in this situation to make sure we have enough for everyone.
Let's order 90 of each kind of pizza.
Great job, you two.
And since we are the ones ordering it, we should be the taste testers too.
Yeah. Anchovy pizza! Please, April, after you.
You have the first slice.
It has your name right on it.
This one here.
I hear the topping is the best part.
Now, let's try to use the area model to divide by a 2-digit number. Let's say these chickens laid 372 eggs, and we want to put them in cartons that hold 12 eggs each. How many cartons can we make?
We can find that out by solving 372 divided by 12 using an area model.
We will make a box showing 372 as the area. One side of the box will have a length of 12, and the other side is unknown.
Next, we split up 372 by place value. That would be 300, 70, and 2.
Now, let's solve one section at a time. 12 times what number is 300 or less?
Oh, I know that 12 times 20 equals 240, so let's write the 20 on top of the box. To find out how much area is left, we multiply 12 times 20, which is 240. Then subtract 300 minus 240.
300 minus 240 is 60. We move that amount over to the next section and add it to the 70 already there. This section now has 130.
And I know that 12 times 10 equals 120. To find out how much area is left, we multiply 12 times 10, which is 120. Then subtract 130 minus 120.
130 minus 120 is 10. We move that amount over to the next section and add it to the 2 already there. This section now has an area of 12.
I know that 12 times 1 is 12. To find out how much area is left, we multiply 12 times 1, which is 12, then subtract 12 minus 12, which is 0, meaning there's nothing left to divide.
Now we just add up the length of each section to find the answer. 20 plus 10 plus 1 equals 31. 372 divided by 12 equals 31.
So we can make 31 cartons of eggs.
Let's try it.
Hey, it really works.
Excellent. You can see how this area model works for any number. It just takes a little practice. Now, let's review.
Today, we learned how to do division using an area model.
We saw that this strategy helped us divide 2, 3, and 4-digit numbers more efficiently.
And we learned that this knowledge helped us count fossils, plan a pizza party, and celebrate our school spirit week.
And now you know why you need to know this. I'm Adesina.
I'm April.
I'm Marcos.
And remember, until next time,
Always question, always wonder.